We've just seen how to do a succession of transformations of functions. And there are two things we really noticed. One, if you've got a collection of transformations you're doing, you've got to be really careful about making sure at every stage you write down what the function is, just so you don't get lost. The second thing we saw was the order mattered enormously. If I give you two transformations, f and g, doing f first then g may be different than doing g first and then f. For example, doing reflection on the x-axis and translation up by 1. The order of those two matters in general. So those examples were basically, I gave us some transformations and asked you, or we together worked out what the end result was for the function. So it is an important problem, which is kind of the same thing in reverse. Important problem. So find yourself a succession of transformations going from some function or some graph of some function y as f of x to y is equal to, so I'm going to write it like this, capital A plus b f of cx plus d. And I don't think I need all of these parentheses. There we go. Where a, b, c and d are all constants. So these are all fixed constants. So this is the general problem I want to look at. So if I have a starting point f of x and an end point that looks like this, I want to come up with a succession of transformations which will get me from point A to point B. Okay? So again, I've mentioned this before, but the golden rule of this is making sure that you are incredibly methodical at every stage. Golden rule. At every stage. At every stage, always write down the new function. So for example, if I do a translation up by 1, write down what you get. F of x plus 1. If I then do a compression by factor 2, horizontally, write down that new. If I then do a reflection across the y-axis, write down the new function. So that means at every stage you're cataloging exactly what it is you have from your start point. It's like after every step, taking a moment to think, what have I got? What have I got? Rather than only trying to worry about what you've got once you've run 100 meters, right? You don't want to do that. You want to make sure that every single step you know exactly what you're dealing with. So this is all about being methodical and careful and writing everything out neatly more than anything else. And not just trying to stare into the sky and come up with an answer. All right? That's not mathematics. It would be tempting if we could all do that, but we certainly can't. What matters more than anything else is being able to completely, definitely get the answer correct and doing so in a way which is understandable to someone else. And staring into the sky or just writing down some answer out of nowhere, no good. So there are many ways to solve a problem like this when it comes down to it, this important problem. And I think really I want to illustrate the key dangers which I think a lot of people make when they're doing this. So as I said, there are many ways to solve a problem like this. You could be translating up all sorts of different combinations. I want to show you an incredibly safe way of doing it. So yeah, there are many ways to solve such a problem. So I want to kind of talk you through a pretty safe approach, which will always work once you've understood the key ideas. Right, so here's an illustrative example, or an instructive example. So this one's going to be a bit simpler than the general case for sure, but it will kind of capture the basic ideas. So imagine I'm starting with y is equal to x. Very simple. And I want to come up with a succession of transformations which get me to y is equal to 2x plus 4. Now, it's possible to do this in kind of two different ways. One is altering the outputs. So altering the outputs as we go along. The other one is altering the inputs, so altering x as we go along. So I'm going to do it from two different perspectives and illustrate to you why they're a little bit different. So if I'm going to alter the outputs, this is going to give me vertical changes. So I'm going to think about things vertically here. So we're going to do vertical changes. So when I say that, basically we're altering the outputs. So I'm going to show you three different approaches to this. Okay, so starting off over here. Let's imagine I'm starting with y is equal to x. Now, what do I see? I see a 2x plus 4 there. So let's deal with the 2x first. It seems obvious. So let's vertically stretch by factor 2, right? If we're going to do things vertically. So that does what? That multiplies the entire output by 2. So this would just be y is equal to 2x. Very good. And then, well, let's just translate up by 4. Just adding 4 to the entire output, so adding 4 to 2x. Translate up by 4. So then we're just going to add 4 to the whole output. This gives y is equal to 2x plus 4. End of story. Brilliant. However, I chose to do the vertical stretch first, followed by the translation. Imagine if I wanted to do it the other way around. So let's do it the other way around. So let's start off with a y is equal to x. So I'll do it in red. Okay, so now what I'm going to do is the translation up by 4 first. So that gives what? Y is equal to x plus 4. So then let's do the vertical stretch by 2. Everything feels totally fine so far. Vertical stretch by 2. So I get y is equal to 2 times the output. The output is not x. It's x plus 4. So this is 2x, not plus 4, but plus 8. Horror of horrors. So if at the start point I had said to myself, oh, we obviously translate up by 4 and then we stretch vertically by 2 because of the 2 and the 4. If I had done them with the translation first and then the vertical stretch, it would be wrong. So this is incorrect. Curious. Now, there is a way to fix this. Right? There is a way to fix this. And you can maybe guess what it is. The problem really is down here. I need 2x plus 4 out. So in order to do that, I could have replaced this 4 by a 2 and then apply the distributive law. But there's a bit of a pain with that. So this is a fix. So if I start with y is equal to x, then I do something which isn't obvious. Let's do translation up by 2. So translation up by 2. Oof. So I don't like that because I needed to think about that. The translation up by 2 really isn't obvious at all from what we've got. So then once I've got that, then I can vertically stretch by a factor 2. So if I vertically stretch by factor 2 now, then it's going to work. Because I would get y is equal to 2 times the output. Remember, we're doing things, we're messing with outputs. So this is 2x plus 4. Bingo. But bad, right? Because this guy here is not obvious. See, it's possible to do it, but I've got to think quite hard. So I think we can all agree the first option is by far the best, right? Or the easiest. If I'm going to be doing things vertically, it seems to me that doing a vertical stretch before the translation is a good plan because it's so much more obvious what you should do, right? You start off with that, 2 and the 2, and then you translate up by 4, translate by 4, all good, right? It fits together beautifully. But if you do it the other way around, horror show, it doesn't fit together correctly. So this is kind of getting at this nasty point of the order really mattering and being very careful at each stage. So without question, the most obvious choice is this, right? It is the most sensible choice to go from x to 2x plus 4 if we're using outputs. Because the middle one is wrong, and the fix for it involves some clever messing around with the translation, which no one particularly wants to do. So that's messing with the outputs. What about if I did this by messing with inputs? So that means messing with things horizontally. So again, we've got y equals x, and we're going to try to go across to y is equal to 2x plus 4, okay? And I'm going to do things horizontally. This is a special example that you can do them both vertically and horizontally. It won't be true in general, but it kind of illustrates the core points. Horizontal. So this is where I'm going to be messing with the x, not the output. So altering inputs. So let's do the same basic thing. Let's do the same basic thing. So why don't I do what I did above? Let's do the stretching first and then the translating. So I've got to go from x to a 2x. So that means I've got to replace the input with 2 times the input, don't I? Okay, so I'll start off with y is equal to x. And I'm going to, what we're going to do, we're going to horizontally compress by factor 2. So that gives me what? That gives me y. This gives me y is equal to 2x. It's me replacing the input x with 2x. I know it's the same as the previous example. That's kind of a fluke of this case. Okay, so then what? Well, at this point, I mean, what would you guess? You'd probably guess if you're going to add 4, adding 4 would be translation to the left. So if we replace x by x plus 4, that's what we would kind of guess. That's translation to the left by 4. So this is what I think we'd all guess from this. What does that give? So again, let's write this super carefully. So this is y is equal to, okay, translation to the left is changing the input alone. So this means the x would be replaced with x plus 4. Exactly the same problem as the previous case. 2x plus 8. 2x plus 8. And that is wrong. So this is incorrect. This is incorrect. Horror of horrors. So if I'm going to mess with the inputs, then it's bad, right? Doing what I did up here, which was the stretch first, then the translation, fails. Here, doing the stretch or compress, the same thing, first, and then the translation gives me the wrong answer, at least if I make the obvious guesses. If I guess 2 and then 4, which you pretty much would do from this, wouldn't you? You get the wrong thing. Oh my goodness. So, is there a fix to this? Well, there is. You can do basically the same fix as before, but it requires thought, right? It's not easy. So here's the fix. So we'll do the same thing. We'll do the horizontal compression again by factor 2. So that's altering the input by multiplying it by 2. So this gives me y is equal to 2x, all good. But then the problem really is in the plus 4 here. I need to do a plus 2. So it's the same story as above. I've got to kind of go into the kind of the nitty gritty and realize, well, actually, I don't want to translate left by 4. I want to translate left by 2. And what does that give me? Y is equal to 2x plus 2. So that's correct, 2x plus 4. But again, it's the same deal as before. This translation there is not obvious. You need to think very carefully about this to get everything to match up. So this choice is not obvious. Okay, well, let's try the other way around. Let's do the translation first and then the stretch compress. So if I start with the translation first, so translating left by 4, which kind of makes sense because of the plus 4 in there. What do I get? I would get y is equal to x plus 4. And then, let's do the obvious guess. Let's horizontally compress by factor 2. But then that's replacing the x alone with 2x. So we're not multiplying the entire output, we're just changing the input. This is y is equal to 2x plus 4. Awesome, it's correct. So I don't think there's any argument here. This is definitely the most obvious choice. So let's just take a moment to grapple with what this is saying. This is basically saying the following. If you have a situation like this, and you're going from x to some kind of linear type thing, 2x plus 4, if you're doing things vertically, it feels that you should do the stretching and compressing first, then the translation. That's the more obvious choice. You can read it off more immediately. However, if you're doing things horizontally, so messing with inputs, then it's flipped. Turns out that you should do the translation first and then the compression or stretching. Right? It's more obvious from this format. Right? If it's written in that format, 2x plus 4, for example, it's kind of more obvious what the numbers should be if you choose these orderings. So this is terribly difficult. Let's try and come up with a conclusion here in general. So conclusion. It's a really nice piece of mathematics, but it's fiddly. You've got to really pay attention to the details. So if I've got a function y is equal to f of x, and I want to come up with a succession of transformations which go across to this guy. So y is equal to a plus b times f of cx plus d. So let's take a moment to think about what's what in this story. So first of all, the b and the a, they're affecting the output really. So the a and the b pieces, this is kind of their outputs. So I think if we're going to go from one side to the other, we should deal with these as outputs. So we want to alter the outputs here. If I want to introduce these. So what we just saw was, in this case, doing vertical stretches and compressions should be done first, followed by translations. So I think to find or to get A and B into your story, that's what you want to do, right? So we want to do vertical stretch, stroke compression. Then you do your translations. And I'll talk about reflections in a second. That seemed logical, right? They are outside of the F, so they should be treated as alterations of the outputs, I think. On the other hand, in here, these are clearly things we're going to have to alter as inputs because they're inside the function F. So we're going to have to alter inputs here. And if I'm altering the inputs, well, we sort of around. We should do the translations first and then the stretching. So we should do the horizontal translations. Then we should do the horizontal stretch and compress. So what does that really mean? So let me give you what I think the safest order is, basically, to doing a problem like this. So to go from the left-hand side to the right-hand side, I need to give you a succession of transformations, like horizontal transformation by something, vertical translation by something, ... right? So here's the safest order, in my opinion. So here is a safe order. I don't want to say there's only one. So a safe order of transformations. So this is just one of several potentials. And what I mean really is the following here. So one that makes each step fairly obvious if the target is in this form. So one that makes each step fairly obvious. We don't need to do anything crazy like scaling translations. Fairly obvious if the target is in the form as given above, as given by this. So if that's the target, the following order is pretty easy to read off. So what I'll do is I'm going to do horizontal stuff first, followed by vertical stuff. You could flip this, but let's do horizontal first. So I would say do horizontal transformations first. Horizontal translations. Followed by horizontal stretch compress. Remember we decided that was a good order for this. So this is altering the inputs. Then let's do the reflection potentially in the y-axis. They may not all be required, you may not have to do all of these, but the next thing I do is reflection in the y-axis. So that's kind of all the horizontal business. Once you've done that, you kind of go across and do everything backwards, but for the vertical. So I would do reflection in the x-axis if necessary. So this is where you're going to mess with the outputs. So this guy, you are going to be doing what? You're going to be... So then let's do it backwards. Let's do vertical stretch compress. And then finally, the last thing you should do probably is the vertical translation. So let me kind of just say what each stage would be here. Am I going to do this? Yeah. So let me just say. So if this is the case, and you're going from this guy to this guy, this is what each step would be. I haven't thought this through entirely. Let's just see what happens. The horizontal translation would correspond to x being replaced with x plus d. That gets the d. The horizontal stretch compress would correspond to x being replaced with cx. Right, so it's easy to read off from the format we're given. Of course, the reflection of the x-axis, x would be replaced by minus x. Okay, so if c, for example, was negative, so maybe this is the reason I've been a bit foolish. So it shouldn't be c, it should be the absolute value of c, really, times x. When we're doing this horizontal compression and this kind of business, we were always multiplying by something or dividing by something positive. So then, down here, so the output, whatever you've got at that stage, would be replaced with minus the output. And you would need to do that, so this is basically only if c is negative. And the only reason you need to do this bit is if b is negative. If b is negative. Then what? Well, then you're going to do vertical compression or stretching. So that would give you, now this would be the output. The whole thing would go across to, okay, so if b is negative, you don't want to use b, but let's do the absolute value of b. So if b was minus 2, you'd do the reflection in the x-axis first, and then you'd do the stretching by 2 in that case if it was minus 2. And then finally down here, I mean, it's just going to be translation by a. It doesn't matter if it's positive or negative, so this would just be the output. The output is going to be replaced with the entire output plus a. So you see, the reason this is safe is because each stage, it's pretty obvious from this format what you're doing, right? You can read off each piece fairly painlessly when it comes down to it. So let's do an example, shall we? So I know that's an awful lot, but that's kind of a really comprehensive overview of this. So if you understand all of this, you're fireproof. There's no problem I could possibly give you that you wouldn't be able to do. So let's do a specific example, shall we? So I'll kind of go back and forth between this in a second. So starting from the graph y is equal to f of x, what's the function y is equal to f of x, describe in words or maybe I should say find a succession of transformations giving. Okay, so let's do y is equal to 1 minus 3 times f of 2x plus 1. So this is exactly the right form. A is 1, b is minus 3, c is 2, d is 1. So let's go through this route, shall we? And let's make sure at every stage we are incredibly carefully writing everything down. No jumping through tons of different things. Let's make sure at every stage we've got a rock solid function in front of us. So we'll start off with y is f of x. That's my start point, isn't it? So the first thing I should think about is what horizontal translations. I see a plus 1 here, so I should translate to the left by 1. So translate left by 1. So this corresponds to x being replaced by x plus 1. So this is y is equal to f of x plus 1. So we've started the game. Next, horizontal stretch and compress. That involves changing the x for something. There's a 2 there. We should definitely horizontally compress by factor 2. These are quite fun to do once you really get the idea. But it's a lot until you've kind of really internalized it. So horizontal compression by factor 2. So that corresponds to x goes to 2x. So let's do that. So if I replace x by 2x, it's y is equal to f of only the x changes, 2x plus 1. Awesome. Next, do I need to... So remember, that's only the x changing. So just as a warning, again, I've said this quite a few times now, but I'll say it again. Warning, this is not equal to f of 2 times x plus 1. It's not the same at all. You're not multiplying what's inside f by 2, you're multiplying the x alone by 2. See, this can't be correct because this would be f, the distributive property would mess everything up. It's this issue we've seen a moment ago. Okay, so now do I need to reflect in the y-axis? Well, I don't need to reflect in the y-axis because my c is positive. Right, there's no need. If it was minus 2 here, I need to replace x with minus x, but I don't need to. So I can skip that step. So then I say, okay, what about reflection in the x-axis? Do I need to do that? Well, yes, I do, because b here is minus 3. So the next thing I'm going to do is reflect in the x-axis to get a negative in front of the f. So let's do reflection in x-axis. So yeah, that sends the output, so let's get this right, the output goes to minus the output. So in this case, what have I got? Y is equal to, it's pretty simple, minus f of 2x plus 1. So next, vertical compression stretch, do I need it? Well, yes, because I've got a 3 here. So b is minus 3. The minus is being dealt with now by the reflection across the x-axis. I need to stretch everything out by a factor 3, so the absolute value of minus 3 here. So I need to vertically stretch by factor 3. By factor 3, so that gives me, what is it? Well, in this case, it's the output gets replaced with 3 times the output. Pretty straightforward. So this would give me y is equal to just minus 3f 2x plus 1. And finally, I've got a 1 at the front. I need to translate up by 1. Nothing complicated about that. Translate up by 1. So that gives the output goes to the output plus 1. So putting everything together, what do I get? I get y is equal to 1 minus 3f of 2x plus 1. Done. And we're finished. We've made it to my target. So this is a really important skill, right? Because it involves picking apart a fairly complicated thing into very simple steps. It requires you yourself to make a choice of each step, right? So it requires practice and experience. This safe order I've given you is safe, but you should really understand why you're doing it in this order, because if you don't, you can easily mess things up. But if you get the orders the wrong way around, this can fail. Or at least it can be very difficult to spot appropriate things. The problem is in the translations. If you get the translations mixed up with the compressions, then you may have to translate not by D, but by something else, right? Which could make life very difficult for you. So this is a safe order as long as it's been given to you exactly like this. If I was to give it to you in a slightly different format, there may be a different order that's safe. But this is the order we've looked at, so this is sensible to single out as a safe order. But really, the golden rule is, no matter what you're doing, at every stage, write down what your function is. right? If you say, I'm going to do a reflection now, write down what the answer is. You see, if you're not writing it down, it's absolutely impossible to keep track. And if you make a mistake, you'll never know where it was. Whereas if I had made some mistake at some point, if I had actually written a -1 here, for example, and it had kind of had this knock-on effect with a minus all the way along, I'd get the wrong answer, but then I'd be like, well, where did it go wrong? It went wrong at the very start, where I accidentally did a takeaway as opposed to a plus. So this is the reason you want to do this incredibly meticulously, just so you can keep track of every step. And more than anything, this is just good practice in taking a complicated problem and breaking it into easy single pieces, something we've been talking about all the way along, right? Difficult problems should be broken down into simple steps which are really like carefully written down so anyone whatsoever can follow them.